Another topic from class is pedigree charts. And pedigree charts are used to show biological relationships, and it's in particular following one trait at a time. And it's important to understand what disorder or what trait you're actually following and how that trait's inherited. Is it a dominant trait, or is it a recessive trait? Is it codominant, incomplete dominant? And that's important to know at first. And in this class, we're just going to work with simple autosomal recessive. That's what they're known as, autosomal recessive pedigrees. So some basics: a circle represents a female, a square represents a male. The shaded individuals, so this one and here, I'm pointing to all of them, those shaded individuals all are going to express the trait. The unshaded are individuals who don't express the trait. They could be considered normal or carriers. If you notice this line connecting these two, that shows a marriage or some type of union. And then they're connected with a bracket that shows that they have children. They have a son and then two daughters. This son is married to this individual, and then they have two children. This couple has three children, so two sons and one daughter. Sometimes you'll see Roman numerals identifying the generations, like first generation, second generation, and third generation. We've followed some important steps, and I encourage students to keep going back to these steps when attempting to solve a pedigree, because it simplifies the process, and you kind of can't go wrong this way. So the first step is to create a key. What are your possible genotypes and phenotypes? The next step is to label all your known genotypes. For example, we're going to work with albinism, and we know that's a recessive disorder. So anyone who has albinism would get 2 lowercase letters. For step 3, all your unknowns are going to at least get 1 capital letter, because this is a recessive disorder. Step 4, you determine by looking at parents or offspring if the unknown is homozygous dominant or heterozygous. Step 4 is really where you would be doing a Punnett square. At this point, some of you don't need to do a Punnett square. Some of you do. You can just jot it down on a piece of paper and just kind of try to prove to yourself what the parents are, what they could be. Step 5 is if you cannot determine. For example, if you can't determine because there's only 4 offspring, if an individual is homozygous dominant or heterozygous, then you're going to label it with a question mark. And it's important to understand that this is useful information for somebody like a genetic counselor. It's a person who works with families and individuals to review genetic testing and diagnosis. So this is a really serious topic. This also can be used to just determine maybe who in your family has a particular trait, like rolling their tongue, or we're going to taste PTC paper, if you're a taster or a non-taster. So it can also be used for helpful information, just if you're curious in your family who carries certain traits. So this was a sample we did in class. So if you need to, you can pause and you can attempt to solve the problem yourself using the steps, or you can take a look at the correct answers here. What we did, we started with the purple lettering, and we labeled, we created our key over here. So fast twitch is going to be either homozygous dominant or heterozygous, and slow twitch is going to be 2 lowercase letters to show the recessive. So, and it says right here, fast twitch muscles dominate over slow twitch muscles. So step 2, if we go back, is to label all known genotypes, all the recessives. So we went along, and anybody who was shaded, we labeled them with 2 lowercase t's. Okay. The next step, if we go back, is all unknown get at least 1 capital letter. So if you go back, you can see capital T's for everyone in purple. There we go. And then step 4, determine by looking at parents or offspring if the unknown is homozygous dominant or heterozygous. So again, we don't necessarily know, these unshaded, if they're homozygous dominant or heterozygous. So if you take a look at 1 and 2, I did some Punnett squares. So this is the father right here, but the mother, if we're trying to figure out if she's big T or big T little t. And this one's a little tricky because all of the offspring exhibited fast twitch muscles. So really, it matches a Punnett square that's actually, I take it back, this is the Punnett. It matches this kind of Punnett square here where it's a capital T. So all of the individuals are heterozygous. Now, I did put a question mark here because if we made this a lowercase t, realistically, the mother could have had some individuals, like half the likelihood of some recessive individuals. We don't see that, but there's only 4 offspring. So that's not a really great sample size. So I did put a question mark here. The way we know that the second letter for 5, 6, 7, and 8 is the lowercase t is because if you look at number 1, that is the only allele that he has to give the offspring. And each parent has to contribute 1 allele or half the information. So that's how you know that that's where they got the lowercase t. And then we continued to look at 3 and 4. They had an offspring that was recessive, so they must have been responsible for also giving the recessive allele. And then if you go down to 8 and 9, again, they had offspring, and I drew arrows here to show they had to have contributed the recessive allele. Number 13 and number 11 are also question marks because we're not exactly sure. We can't really prove if they're homozygous dominant or heterozygous. And if you take a look, looks like at D, what's the relationship 12 has to 2? That's going to be grandmother and grandson. There's some practice problems for homework to do and that have to do with being an albino. And so take a look at those and see how you do. And if you have questions, please see me.